Scripture.
Wait,
Let's go. Scripture.
Boy, I should say something, but I'd get myself in trouble. Okay. Okay, so what we're wrong on so many levels, Wade. Alright. So kind of on Facebook. So what we're gonna work on today is analyzing and sketching graphs, but our graphs are gonna be a little bit different where our X and Y are not gonna have a scale. We're gonna show like what's happening. So what I want to do is volunteer one. I'm going to draw this. And Troy, you're going to be volunteer one. I want you just to walk to the front, and it says walk slowly to the front in a straight line. That's all you have to do.
I can't even step over that chair. That is
Don't
not
stumble.
low.
Alright, now start over there. Okay, so if I was to graph what just happened, I look at my graph and I see that I have distance from the back wall and time. Before we even start with this, what type of correlation should we have? Positive, yeah, because as you walk away from the wall, when that gets bigger, well, time's going to go. We can't reverse time. So we should have a positive correlation. Because Troy walked in a steady pace, which is our constant rate, it didn't vary, he just walked one solid. I'd represent this with a failure with starting point at 0. I would use this. And the line that I drew, it's a straight line, a linear line, because his rate stayed the same, and the distance from the back wall, it increased, and it increased with time. Alright, Wade, I need you to walk quickly from the back to the front.
Step over the chair.
Do it again.
Alright, move over. Now, Wade's going to have straight line, stayed at constant pace, but what was different between Wade? Well, there's a lot of difference between Wade and Wade. But talking for the pace, what was different about how fast he was going?
I feel like it was the same time.
Should have been.
I can do it again.
Now, we want to say Wade needed to be walking faster than Troy. So keep that in mind. Wade messed it up with his cowboy walk. Now, how would I graph that? What would be different? Their starting point would be the same, but what would be different then?
The time.
What about the time?
Like that.
Okay, to get to a certain distance, you're right.
So it would be the same distance, so it would be the same like height, but like going like.
Awesome. Okay, so Zach kind of hit what we wanted. The steepness of the line needs to change. On this one, since Wade was walking.
Why is mine always so necessary?
Okay. Now, because Wade was walking faster, his steepness of his line, like Zachary said, would have been higher. I covered more distance in a shorter amount of time. If I gave them both 5 seconds, and let's say this was 5 seconds at the end, Troy, after 5 seconds, his distance from the wall would have been less than what Wade's would have been. Okay, Sierra, her turn.
Right.
I need you to stand at the back wall and not move. Okay, go.
Don't move. Stop moving.
Man, you're nailing this.
Stop moving.
Alright, good. We're going to stop there. How would I graph Sierra?
Straight line.
Where? Up, down, left, right,
No,
down,
you go straight to the right. Oh yeah, you would go
straight horizontal line. have to be. Okay, you two can have a seat. Zero, you can have a seat. Okay, I will throw you a sucker here in just a second. If you're in your seat, otherwise I won't. Okay, hers has to be horizontal because she didn't go anywhere. Now I got a question for you. And I'm gonna make this
There's 3 just right there.
I want a dumbbell.
worth a question.
Hey,
Now,
that's me.
who do you think could? We're gonna use Troy's pace as the guide. How Troy went slow. We're gonna use this blue. Who thinks they could walk to the back wall? And I want you to reenact what I'm going to draw. So what I'm gonna draw.
Let me do it. Wait, stop.
What are you doing, step bro?
Alright, pretend there's no gap there.
Stop.
Oh, shh, don't share it out.
Don't ever say that again.
Mr. System, make the right choice to give me this blue something.
We'll pretend that these are all there connected. I'm gonna change this one just a touch. If this would get off there. Alright. Molly, since you're back there, do you think you can reenact this?
Yes, which one?
The orange. Okay, let's see.
No.
Going back, okay.
I followed the line. Went up and then turned and it went down and then came back up.
Isn't it based off
Okay.
time?
Oh.
Okay.
Now.
Oh, I see. Based off time.
Oh. Wade's making a good point. So we have to listen to this because this is the mistake. You get yourself stuck because you tried. You failed, but you tried. Now, Wade made a good point. He said, wait a minute, I thought this was based off time.
You're supposed to slow down.
So the distance from that back wall, we're going to go a straight line, but it's based off time. So you have to think what's happening. So one other person try it before I give us the answer. All right.
Me, Mr. Chief.
Oh, I'm still going to pick you until you say
Okay.
it. All right, Tegan.
What?
You can try. Molly, you can have a sucker.
This is blasting.
Yay.
Can you stop
Don't make
that?
her move.
Wait, maybe you remember this last night.
What am I doing?
All right, start at that wall. How can you show this?
Which one?
Orange.
Okay, so it goes. So I start right here, right?
Okay.
And then I go.
Based
Oh,
off
no.
time.
Wait, let me go.
Then I
Then I have to go back.
I can literally tell you what to do. I don't even have to look it up.
Yeah,
I can tell you.
Not too far up.
Oh! This is
Last one. I guess I'll do 3.
I can do this.
All right, Ty.
What?
I do it. I hope I
Stay
do.
quiet.
I know I'm. God, you already know things.
All right, Ty, you're our last hope.
Okay. What? I stopped
Close.
like twice.
What? That was perfect.
Almost.
I got it.
What was the mistake, Benjamin?
When they went, when the arrow was down, you should have come back.
Very good. So, if we read this, here's our starting point, and we're doing a constant increase. And because it's a straight line, it means it's constant. It's just an easy pace. When we got here, she did that perfect. She stopped. And she waited. Time went on, but no distance changed. The mistake she made was, then she went forward again. But what did our distance from the wall do? It dropped. So what's that mean?
Slow
Should
down.
have went backwards. So she should have went forward, stopped, then walked backwards. Because now we see this is the distance from the wall. Here's the starting of the wall. I'm now closer than I was before. So we'll say backwards. Or just back.
Can you draw another one?
Then as soon as she went backwards, she should have stopped And then how should you went in forward?
Fast.
Same speed? No, so it's a steep hill. It should have been like she came back and then boom and sprinted forward because it was steep. Fast. Okay. I'm gonna have 3 dum-dum suckers for this one. I feel.
Why did you do that?
Zigzags, even going back to this one, was showing that we had change. If I had just like Troy in blue, Troy went from the back wall to the front. He just walked straight pace, right? But if I went and did this, let's pretend this is the back wall. If I went here, solid pace, but then I stopped and I went backwards, that's where we're going to show I went at a solid pace, then I went back towards the wall. But remember, I still have to go forward, left, right, because time is going on. When I stopped and went backwards, it's not like the time stopped and we started going back in time. So the time still went forward, but my distance decreased, and then I go back forward again. Okay? Here's what I want you guys to try. I think this is in your notebook. Is this on the purple sheet?
Yes.
Okay. I'm going to give 3 suckers for this. There's 4 graphs. The reason I'm giving 3 is because the 4th one is automatically determined then, but it says each graph shows your speed.
Bam.
So speed, this is our speed increasing along with our time. So each graph shows how fast our bike is going over time. There's 4 scenarios. You need to match up A, B, C, and D with the scenarios. They are you increase your speed, then ride a constant speed along the bike path, then slow down until you reach your friend's house. You stop. You ride at a constant speed, then go up a hill. Once on the hill, you increase your speed. You increase your speed, go down a hill, quickly come to a stop at the intersection. Increase your speed, then stop at a store for a couple minutes, then continue to ride, increasing your speed. I'm going to pause. I'm going to give us about 1 minute. Turn, work with the neighbor. Can you place these 4 where they go? All right, so here's my hint to you. 2 things. We can have started either way. I can either start at my graph and say, okay, this is what's happening. My speed, I'm at a speed already. I'm already at a speed. My bike is moving on this B. I can see I'm not starting at a standstill. I'm already moving, and I'm going steady. Or we can go in here. If I go in here, I'm going to do our first one. Actually, let's have someone give me an answer, and then I'll talk about it. Ainsley, what did you get for an answer? Okay, so she got C. We'll check it. What I would do is say, you increase your speed. Okay, so I'm thinking that means over time, left to right, it's going to be going up. Then I ride at a constant speed, horizontal line. Then I slow down until I reach my house or a friend's house. So it should go down. So I'm thinking if I put these all together, it would look something like up, straight, down. C is correct. I started here. I increased my speed. My speed's getting higher. Then as time went, it stayed the same. Then it slowed down. And the reason I got to here, this is 0. I got to 0 because I stopped at my friend's house. When I stopped there, am I going fast anymore? I'm all done. Good job, Ainsley. Second one, you ride at a constant speed. Then you go up a hill. What do you think is going to happen when you go up a hill? If you've ever ridden a bike before, probably going to slow you down. Once on the hill, you increase your speed. Braden. Okay, I ride at a constant speed. So I'd be going up. No, this is increasing my speed right here. I'm already increasing my speed, so it can't be A. Zach? Nope. B. Okay, B. I ride at a constant speed. Horizontal. Okay, that's a constant speed. I go up a hill, which means I'm going to go slower. And my speed's dropping. On top of the hill, I increase my speed, and it'll probably come pretty quick.
I said
increasing my speed. I'm on B. All right. So B is correct. Good job, Zach.
Zach the Black.
Wait, you mean half
All right. Last one, another one gives you the answer. You increase your speed, then you go down a hill, and you quickly come to a stop at an intersection. So we've already done B. We've done C. Alex? Let's see. I increase my speed. Okay, looks like I'm increasing my speed to about there. Then I go down a hill. So my speed's still increasing this whole time. From here to here, I increased. But this one right here, I increased faster because I'm going down a hill. Looks good. I come to a stop at an intersection. I quickly come to a stop. So it means quickly stop means my speed, I probably slammed on my brakes. I'm coming down that hill. I'm like, oh my God, there's a car coming. And I locked them up so it's going to decrease quickly. I get to here. I'm all the way down because I stopped. I have no more speed. A was correct. Which means last one have to be D. Alright. I do have a sucker for this one, but I need to see if you guys can figure this out. Work with a partner. There's more than one answer. There isn't a set one.
I think I got this.
To determine what's happening in this graph and explain your thinking. I'm going to let you turn and talk to a neighbor quick. The thing I am going to point out,
Mr. Chief.
we're looking at height and time. In height, this is 0, so we're already off it just a little bit. Turn, talk. What do you think's happening here? So, let's look at this now. Shh. Right here. Wade, what do you think?
So I think it's how much he grows, and then like at the time when it's all the way down, it's like look, it says height.
So you're telling me.
Wait.
So you're saying.
Yes, it's when a person shrinks and
That's
then they
a
grow,
weird
and then shrink, and then grow, and then shrink. And
I
then
got
grow.
taller and then I got
You
shorter.
said multiple answers. So where's my sucker?
But a person's height, no.
You never know.
This-
Maybe
this
they're on
height
something. And
is not going to be getting bigger than smaller than
where's
bigger.
my sucker?
No. Then. Oh, listen up. Let's finish this.
Climb the mountain range and then go throughout time. Yeah, I know.
Maybe.
Oh, I got a scenario.
There's a reason I like. Okay, if you listen to what he said, I'm going up a mountain range over time. Okay, maybe, but I'm going to talk to you about that in a second. Sierra?
So you know like how hills, like some really steep hills are like that?
Okay.
So you could be riding the bike and then you go down and they stop at the bottom part.
Okay. Here's, okay, good idea, but here's why I'm going to say no to that. Now,
Mine was the most
look at
recent.
the steepness. This is what we have to pay attention to in our lives. One, each time we go back to the same height. We have the same height each time. We also have the same, like, bottom of the height, the low of the height. So it's got to be the same. So one, if we said, like, climbing a mountain stuff, well, I don't know about that. If they'll always be the same. But even if we said it's the same, here's the other problem I have. The spacing, how long it takes to get to the top is the same each time. And the third thing to pay attention to is, look how long it takes me to get to the top. To go up, to go down, it's the same pace. Now, if I was riding my bike and I went up a hill and down a hill, am I going to go up the same speed as down the same speed? No, we just did those examples. We showed going up a hill, we probably go slower. Down a hill would be more steep. That could be. We could say an elevator. The only problem I have with that is we don't have any stops. And it never stops for people to get off. I would think the elevator would
I know
stop.
what scenario.
foot, unless you're like
That's like 5 hours.
Maybe a roller coaster, but still, maybe you could control that.
Maybe if you're on one of those pretzel things, you're just pressing the
Oh shoot.
I know an
Up and
answer.
down thing.
Oh, the angle.
Oh,
I know
we
a
can
scenario.
go over a fence.
Okay. Follow on so we can continue moving. Don't know if there's really an answer to what this is. This is probably a wavelength from like sound. We did some of these. We talked about maybe it's someone jumping or someone lifting. If I have weight, maybe it's me lifting something up and down, up and down. Same range motion, and I'm doing this. You would probably. Okay, we are close. We are close to being done. The key concepts. Pay attention to this so we can finish this up. We have 2 examples left. Key concepts when we're drawing this map are 3 things that we really have to notice. The first one, when we have our 2 coordinates, whatever, when we are going up at a positive slope, that is going to be showing us our increase. Remember, the steepness is going to say to what amount. So this one is distance over time. That's slope going up. If I went faster, my steep would be higher. If I went slower, it would be more gradual. The second part that we have to understand how to do is if you draw a horizontal line, that's going to say it's a constant. I'm having no change to my y-axis. Remember, is it changing on my x-axis? Yeah, I'm moving left to right. So it's no change on the y-axis.
Newport, Oregon one looks like my grades.
And then the last one, if it slopes down, that shows us that we are decreasing. We're having a negative correlation. Okay? We have, I don't know if I really want to, we'll discuss this quick. We're not going to write it. Here it shows temperature. Now, if we look at these 2 cities, the first one in Maine, if we look at this, I would say this first one,
It's my pencil.
the first one is showing what we would kind of expect in a typical day. Braden, are you folks with me, bud? Okay. So, this is what I'd expect in a typical day. My temperature, as the day went on, is gradually increasing, and then it gradually decreases. That's typically, like in the summer, what we should have. In the morning, it's cool. It starts gradually getting warmer as the sun comes up. It's at the top. It stays warm, and it starts, as the day goes on, getting cooler. That's typical. Why in Oregon do we have a straight line then? This one was not a linear. We don't have a slope saying every hour it's going to go up 2 degrees. Why is this one a straight line? What could possibly be the explanation? Maybe they're starting. That's good. Maybe we're looking at a different time of the day. Tegan? In just a second. We're almost done with this.
Oh, that explains it.
Could be different times of day. If we look at this, I probably expect Newport, Oregon to be maybe during a storm or something. When we see that our temp dropped fast,
That's a tornado.
do we have that happen just on a regular day? Does our temperature go from 0 to 40 real fast?
No.
Usually.
Global warming.
Yeah, usually that's our gradual. But have we had this? We've had something like this happen even this year where in the middle of the day, we knew a storm was coming. They talked about that cold front coming through, and it was like 50 degrees, and in an hour, it was like 35 or something. That dropped the temperature
That's
fast.
drastic.
Yesterday?
Okay? So the difference, this might have been with a storm. It might have dropped down, and then it was like a freezing temperature for a while. And then as the storm passed through, then we started increasing our temperature. Here's what I want us to do. Last 2 problems for you. Last 2, and then I'll give you your homework. First one.
I know how to do it.
These are going to be worth a dum-dum. I'm going to ask someone to come up to the board and draw what they think their answer will be. but I want everyone to do it together in their notebooks. So, it says sketch a graph. I will tell you we will start here at 0. I'll stop subway train. That's why we're at 0. Gain speed at a constant rate. So it's going to gain speed, constant rate, till it reaches maximum speed. It's then going to travel at that speed for a while. Then it will slow down at a constant rate until it stops. Go ahead, draw this in your foldable, and then I'll ask you if you can come show it to the class. Question, Ainsley?
Oh. That definitely is not a straight line.
Oh, crabs out.
My face was bloody. My dad was overturning.
Remember, you have a curve. Is that a constant
I'm not trying.
Remember, a constant speed means you have a straight line.
Oh, how about there?
Yeah.
Me.
Yeah.
Me.
Does that work?
Ryan, come draw.
What?
Give me that one. Everyone else, you can do one with the second one.
Wait, there's
What about the color? Wait, blue. I don't know why I have it copied twice.
You have to be on the wrong one.
No.
Wrong.
not the. It's awful.
I went off the graph.
Hey.
What did you go backwards? Wait.
No, that's
What, the train jumped the triangles?
No. No, what I did.
The crap, right?
Oh my god.
It's like, okay, backwards. This would work. So if we pay attention to this, it gains speed at a constant rate. Follow along with this. It's going at a constant speed. It stopped up here because this speed was its max. So then it'd be a constant speed. We'd have our horizontal line where it's going as fast as it can. Then it slowed down at a constant rate. Straight line. A couple that I came around, I saw more lines like this when they were graphing theirs. Was they went. The problem with this is if this is more curved, it means that it's not going up a constant speed. The conductor keeps just gradually changing the speed, and it's not a linear line. This shows a linear line. I'm increasing at the same rate. Last one.
Again.
Last one. A fully charged battery loses its charge at a constant rate until it has no charge left. There's a trick to this one. There is a trick. Are you going to do this one?
Oh, well, you see if this is right? I don't know if it's right or not. I don't want to get it wrong.
I got
Come
it.
see if
I'll
you
just
have it
say
first.
Okay, well, I copied off of Molly, so it's probably like, you're not
Copy
right.
off ball.
Did you just say you copied off Lisa's point?
Yeah.
Oh, man.
So Molly
Okay,
did the stuff.
so,
right?
Okay, so it's fully charged, so it's gonna go from 0 all the way up, right?
Well, if I do that, that means it's at 0 and I charge it.
Oh, just kidding.
So.
That's not how that
Straight
works.
line.
Oh, I
Oh my
just
God.
deleted
Way to go.
Oh, man, you got a hard crowd.
What?
Hard crowd there.
Ainsley, go straight up.
Alright, now, do we have to go straight up, though?
No.
No, we start at fully charged. So our starting point,
Yeah.
our first point's going to be there. Without any time, it is just charged. Alright, now what would you do?
And then it loses charge at a constant rate.
Good?
So it just keeps
So
going
it's
down.
all the way dead, right?
Yeah.
Okay, and then it says it has no charge left. I plug it in, and it recharges at a constant rate.
Yes.
Straight up.
What?
Then it loses its charge.
McDonald's. McDonald's sponsored this.
McDonald's sponsored this.
McDonald's.
Alright, so follow along, I'm almost done. Let's just explain this one, then you can do your homework. So, I want to hear Troy's question. Yes.
Does it take time to charge?
Now, it does take time to charge, which is why it's a constant rate going up. Remember, this is our charge.
10 seconds.
So that's
It gets to the bottom and then is it dead and then just like fully charged?
okay. That's a great question. We talked about that last hour. Typically, if they would have told us that it loses its charge until it has no charge, and then I say I wait 1 hour before I charge it, this would have been it loses charge. We probably, when it died, I would have waited before I plugged it in. I probably didn't go playing with the thing. As soon as it died, I plugged it in. But that's what this
That's
shows
what I
us.
do. I just literally run it down.
But
It's on the thing that says shut
We
it
would
down.
have, if you do that little constant wait time, because you said, hey, it died, then I went and plugged it in, and then it went back up, and it fully charged, and I didn't unplug it right away, so it sat fully charged, and then I unplugged it. If you could explain that, I would be okay.
Fully charged.
As long as you could say, it died, I didn't plug it in yet, I plugged it in, it was charged, like my cell phone last night, I plugged it in when I went to bed, it was fully charged, but I didn't unplug it right away. So it stayed fully charged and plugged in, it would have stayed constant. This morning when I unplugged it, maybe it started decreasing
We
the charge.
sponsored this.
Okay. I don't know. Okay, your homework, what you need to do for tomorrow. We are doing 7.5. There are a few questions. 1 through 4, or actually it's 6 through 9. You have to use this graph to the right. It says A, B, C, and D. So on 6, 7, 8, and 9, you have to put like 6. You run at a constant speed. Would A, B, C, or D represent that? Then you go, you slow down. What would be the answer? 10, 11, and 12, you need to describe what is happening. This one, you have to write some words. The last thing I want to make sure you're clear on this. There's 2 questions. 18 and 19. 18 and 19, 2 situations, just like we just did. You need to graph them. Here's your graphs. We put the grids just underneath for you. So on 18, the value of a television decreases at a constant rate, then remains constant. Draw that over here. On 19, the distance from the ground changes as your friend swings on a swing. How would you show that here? Okay? That is your homework for tomorrow.